What's going on? Shh. I'm concentrating to resolve one of the most challenging questions of humanity in this century. What? What do you mean? I'm trying to figure out a solution that how we can apply DevOps principles for large language model based applications, or better to say how we apply MLOps for productionizing LLM applications like ChatGPT applications. Well, don't try hard because I have a demo right now that I want to show that how you can use prompt flow in Azure ML with GitHub Actions to apply MLOps for LLM based applications, or better to say LLMOps. No, it can't be that easy. It's a big thing. You don't know anything about it. Seriously, are you okay? Yeah, you were so deep in your role and acting, so just wanted to tease you a bit. I swear he's the one making these ideas for the intro of the videos and making these dialogues and forcing me to play them. So funny. Let's go! Hello my friends, welcome back to another video. Well, it has been a while we haven't talked about MLOps. Well, this time we're gonna add MLOps for large language model based application, or better to say LLMOps. So we're gonna see when we create an app that uses large language models like ChatGPT or OpenAI models, how we can apply those DevOps principles for going from dev all the way to production, making sure that we assess, evaluate, and apply those DevOps principles before productionizing the final solution that uses large language model-based applications. So in this video, we're gonna leverage GitHub Actions plus prompt flow in Azure ML for having a quick demo on how we can apply MLOps. Then, let's check it out.
Before we start, make sure you subscribe and hit the bell icon so you will get notified for the next video. Thank you. Alright, before we get into the demo, let me start with talking about, first of all, what is LLMOps, or how we can apply those MLOps principles that we discussed about before, this time for LLM-based applications, because we are dealing with models, like AI models here, or large language models, but there are some slight differences. If you follow my pointer, let me actually turn it on like a laser, you will see that in typical machine learning models, let's say the old NLP models that were they doing just, let's say, classification or sentiment analysis, or any machine learning model, we do have the training stage that technically the data is the input, we have our algorithm, and we do have our training data. That can be a labeled data to, for example, have a machine learning model to tell us if the given email is spam or not. But now on the right side, when we have these LLM based applications, that's a slightly difference because we still have data. Remember, we have talked a lot in previous videos about how to connect ChatGPT OpenAI models to your own data. That means you're gonna have these models talk with your data, right? We talked about how we can bring your data to the prompt, the retrieval augmented generation using cognitive search, word embedding. So you still need to have your data there, but that data is not the training data. That's the data for the input of the model as a prompt to do something. So here, instead of like having get labeled data or training data, which we don't have it, we do have our prompt with our data to these large language models, and we are not going to train another model from scratch. I'm not going to train a GPT-4 model here, which is not even feasible for me. And then I can have the outcome, the same thing, NLP task or anything. We have talked a lot of variety of different use cases that large language models can be used. So let's take it a little bit further. If we talk about this ops or DevOps practice for LLM application in very high level, and shortly how this is gonna look like. We start with our own data, again the data that we're gonna bring to the prompt. We will discover what large language models are gonna use, what prompt engineering, prompt techniques. If you want to do some fine tuning of some of these models, if it's doable, you can do so and test the performance, repeat the prompt again and again, and then validate. Let's say now I have created an application that received the user input and answer the user's questions about some PDF files, right? So I have to test this end-to-end solution with 20 questions, 30, 100 questions to make sure this chatbot is working properly and it is asking based on my own data. It's grounded based on my data. So validation is still a key, and monitoring. Remember back in the time for MLOps, we were detecting, monitoring the machine learning model performance, the data drift, the stuff. The same concept here. If I have a prompt engineering solution that works today, there is no guarantee that it's gonna work tomorrow, because the input data might get changed for the grounded data, I mean. Or we need to maintain the prompts, maintain the prompt engineering techniques, making sure that we still have this chatbot or LLM application works properly. Chatbot is again just one type of using LLMs. Not always we need chatbot. So when we talk about ops, we are talking about CI/CD, continuous integration, continuous deployment, or delivery. Here, let's deep dive on what gonna be the high-level components when we talk about CI or continuous integration with prompt engineering or LLM applications. The tool we're gonna use for this demo is GitHub Action for our CI/CD, and for our prompt engineering or creating our LLM application, we're gonna use PromptFlow, which is a new service added to Azure ML. So make sure you watch the video I created about PromptFlow first before you resume, because you need to know what is PromptFlow, how it works. That's a whole separate video on topic. I want to add that video to the top right of the screen here, and I will add the link of that PromptFlow tutorial video I created on the description of this video down below. Make sure you watch that first before we resume this video. Okay, assuming that you know PromptFlow, this is what we're gonna do. I'm going to create an LLM application that as soon as I push it to my repository, to my GitHub or DevOps, Azure DevOps, whatever repository that you have, it is going to trigger some CI pipelines for me. And what those pipelines gonna do, they will deploy my prompts, prompt flows, and the chatbot that I created, and they will evaluate it. If the evaluation is good, it is answering questions properly, I want to deploy that prompt flow as a model in Azure ML. Then, if I am happy with the evaluation results and the model is registered in CD pipeline, I'm going to deploy this flow, this prompt engineering, this LLM application as an online endpoint in Azure ML. What is online endpoint in Azure ML? That's a service in Azure that you can deploy your models real time and use it like an API call. Here's the same thing, but instead of model, I have a prompt engineering application. I will deploy it like a model, like an endpoint. So if I have a chatbot that used GPT-4 I created, I deploy it as an endpoint, and I give you the endpoint API. So you can call my chatbot, ask your questions, and the answer is there. That's the whole idea, right? So with having this CI/CD definition in place for this demo, which I actually got the repository of this demo from Microsoft repositories and Microsoft documentation. So I will add the repository that I use and all the codes in the Discord channel on the reference section. So when you open Discord, there's a section called reference. Open that up, you will see the link to the repo, and I'll go through that shortly. So what that code does, before we go through the codes and demo, let me show you what we're gonna do. First, we pushed our codes and prompt flow, our application to GitHub, and as soon as we make a change or do a pull request, that will start triggering this, building this application or deploying this application in my Azure ML. What is this application? It is going to use GPT 3.5 to classify the given web URL. For example, if I give a link to a YouTube channel to this chatbot, it should tell me that, oh, that's a video link. If I give the Microsoft documentation link to this chatbot, it should tell me that it's a docs link, it's a whatever, application link, video link, whatever. So that's an example of LLM application that use OpenAI models on backend. So I go to deploy this, evaluate this, I give some samples, make sure how many times it correctly classify my web classification application. And then if the results are good enough, for example, more than 90% of the time, it can classify a web URL correctly, then I can register it as a model in PromptFlow. Why? Because I want to deploy it at the end. Deploy it as an endpoint that I told you to productionize this, or deploy it in a staging, run it for a couple of days, making sure it's working properly, and redeploy it again in production. That's the whole idea. Okay, so that was the intro, about quick intro, a very short video about LLMOps, difference with MLOps, what's the proposed value, what do we mean by CI/CD when we talk about LLMOps, and what's going to be the demo that we're going to deploy together shortly. So let me go through my prompt flow in Azure ML to show you that application first, to give you an idea what the app is, and then let's see how we deploy, evaluate, and deploy it using GitHub Actions. Alright, here it is. This is my prompt flow inside my Azure Machine Learning Workspace. If you see, click on the left side, you can see the list of your flows. You can create a new one. Again, there's a separate video I added to the video description that I fully talk about prompt flow, what it is, how we can use it. So I'm not going to talk about it again, but it has some examples that you can use or start your own application, LLM application from scratch. Not only you can create your application, but also you can evaluate your application. For example, if you do, let me go to evaluation. If you're doing classification by OpenAI models, that's the way that you need to evaluate your performance, because we are doing classification. And this is pretty simple. If OpenAI says this is a YouTube link, video link, and the ground truth is yes, that's a video, then we got true positive or true detection, sorry. So, but if the output of your LLM application is not just a classification, it is maybe answering a question based on your data, and you want to evaluate that, it's not as simple as classification. So for that, you should use this approach, which is, I think on backend it used GPT-4 to see how your app is working well or grounding the answers based on the questions. So there are different type of evaluation. Again, I explained all of that in that video, but just tell you FYI, this is what we're using for this demo. And for the application by itself, or the flow by itself, we are using this one, web app classification. So it uses large language model. Here we're going to use ChatGPT or GPT 3.5 to classify a given URL to a category. Okay, I'm going to show you how I deployed and tested that with GitHub and GitHub Actions, but let me show you the results first, that you will have an understanding of what you're going to accomplish. This is my flow, the web classification. So you will see that first I'll receive the input from the user, and the input is here. It is, just the URL. So this is, for example, Microsoft URL as an example. So what I'm going to do next step, it's a Python code that fetch the content inside that URL. So it's using beautiful soap. I think I saw that somewhere actually. Yes, there you go. So to parse the content and to see what that document, that given URL include. But there might be a lot of text, and I don't want to give all that text of that link to OpenAI model and tell me what is that link about. It's too much. So let's summarize that first. That's the next step. So I'm using, again, connecting to my Azure OpenAI. I'm going to show you how I created this connection. You have to create it first before you actually run that GitHub Actions and stuff. And then here the prompt says that, hey, I'm going to give you the text that I grabbed from that URL. Just summarize it for me. And then the summarization of that will go to another prompt that, hey, this is the summary of the given URL content. Based on the content that you got, tell me what's the category of this link. And by the way, I'm going to give you some few short examples. Where are those examples are coming from? It's actually coming from here. You see that? So the examples, which is here, is coming from the output of prepare examples step, which is this one. So let's click on prepare example steps. Here are some few short examples that, hey, this is the URL, this is the content we got it from me, and the category is channel. That's a YouTube channel. So few shot. Some of the best practices that you can apply for a prompt engineering. Not a must to have, but good to have. And then lastly, when we give this prompt to OpenAI, we should now have the prediction back, or the categorization back, and we're going to parse the output of that OpenAI prompt using this Python code, and then we have the final output, which is the detected category of the given URL. Okay, so now how we evaluate this, that's another flow that we deployed by GitHub Actions. Again, I'm going to show you the results, and we're going to show you how we did this. So classification accuracy evaluation, that's the other one. So what this one does, this is pretty simple. We don't need even maybe another OpenAI to evaluate for us, because we have the predicted, let's say, channel, YouTube channel, and what's the true value? YouTube channel, true, false, whatever. So first step, we get the input. What is the input? We're gonna see what was the prediction of OpenAI model for the given URL. It's a URL about app as an example. And what was the ground truth? The ground truth was app too. That means yes, that given URL was about app. So these are the inputs that we ship these inputs multiple times for multiple samples to grade it, how good we are grading is very simple. It's a Python code to check if the predicted value is equal to the ground truth or not. And then after that, we calculate accuracy based on those grades that we captured, and that's it. So in order to show the output, I click on view output. This actually, let me see if I can have all the output at one place. View batch runs. Okay, let me go to the prompt flow again, going to the runs. This is the last run that I did for GitHub Actions that I'm going to show you. So it evaluated based on some of the sample test data set that we have in our GitHub repo. And if I see the output, there you go. For example, the given URL was an app and the solution predicted as an app. So I changed all of them to the app to make sure the predictions are app to have 100% accurate model, because I wanted to pass that accuracy threshold to register this as a model. All right, so how we did this, how we deploy this, again, we had this all as a code in our GitHub repo, and then we deployed that through CI/CD GitHub Actions for this. Now I'm gonna come to how we deploy this. But before we do so, a couple of things. If you want to use the GitHub repo that I'm gonna share to have your solution deployed and run this demo, you have to do some modifications, or sorry, configurations. First, come into your prompt flow. Before you deploy anything, create a connection to your Azure OpenAI, because we're gonna use Azure OpenAI for calling and then shipping out prompts, having this web classification working. So click on create, click on Azure OpenAI or OpenAI, give it a name, test, select your subscription, select your Azure OpenAI, put your OpenAI key and the base. You can grab all this information from your Azure OpenAI portal, okay? And then click on save. You will see a connection with the name here you specify will be saved here. The one that I used for this demo is this one. And you can see that I have the information about who created this, what's that about, so on and so forth, okay? So I go back to the connection, and that was again the first thing that you need to configure. The second thing that you need to configure is in your runtime, you want to create a compute to run your prompt flow and application, right? So click on create, give it a name again, and select the compute instance that you have in Azure ML. If you don't have anything, then create a new one. And then click on create, that's it. And you will see a compute with the name you specified has been enabled here. So I use this one. PF stands for prompt for runtime. We can use any name. Make sure you copy this name, and also you copy the name of the connection you create to Azure OpenAI. You will need this to add it to your GitHub, okay? The third thing and the last thing that you need to do before you go to that GitHub and execute the code is creating a service principal. Why? Because your GitHub action gonna deploy this stuff to your Azure subscription, so you should give permission to GitHub to access to this and deploy this. How? We create a service principal, we give it some contributor permission to that service principal, and then give it to the GitHub to use it. How you can do so, there are multiple ways that you can create a service principal, but one of the easiest way maybe is just opening a Cloud Shell. You just click on the Cloud Shell here. Let's wait a bit. There you go, my Cloud Shell is working. Make sure it is on bash, and the command that you need to paste is actually coming from this reference documentation that I used to run this demo, and you will see the GitHub that I use is also inside this documentation. So I add this documentation to the Discord channel. Come here, check that out. You can use this command line that we're going to use. Also, you will connect to the repo as well that you need to fork this, which I already did. So in order to run you need to copy this, hold this, you need to change the project to the project name that you want, keep the role name contributor, paste your subscription ID, environment, prod, staging, whatever you want to put, and the rest, that's it. You don't need to change anything. You just copy and paste this after changing these values, of course, here in the bash. Well, I think it didn't work because I didn't change the names here, or maybe it did. Yeah, I already created one, so I don't need to. So what's gonna happen when you deploy this? It will give you a response like this, that hey, I created a service principal for you, and here are the credentials. You need to keep this, and by the way, this is credential. This is what you need to add. So copy this somewhere. You will paste it in the GitHub. Now we are done with configurations. Let's go to our GitHub. What you need to do, you need to fork this repo. So I click here, I'm not going to do that because I already forked the repo. So I jump to my fork repo, and you can see that I have the same repository here developed for me. You need to change a couple of things before you deploy. Click on Actions, and go to the codes, click on Workflows. You'll see that under prompt flow, web classifications, I have that web classification prompt flow that I showed you, which is here. Now it is converted as a code. This is exactly what we want. The flow that you see here, let me close this extra tab. The flow that you see here that has input, output, input, output is sort of defined here. If I go to the flow, the same stuff, the same thing. What's your deployment name? What's your model name? Your Azure OpenAI connection name? So how did we convert that prompt flow to the code? That's a new thing added. That means, good news is that you don't need to code these. You just need to create your flow as you do here. And recently, Azure ML Prompt Flow added a new capability that it can give you the code automatically for sort of this flow that you're creating. For example, these are a couple of flows that I created before, but where the code of this flow go? You click on your notebooks, you click on your folder name, mine is admin, and there is a section called prompt flow. This will be created automatically, and under that, there you go, that classification stuff I created and deployed, or this is another flow of mine. It automatically gave me all the codes that I need to replicate this prompt flow. That means these are the ones that I'm going to ship to the DevOps repo, which already this DevOps repo have them. So your first potential question is how OMG you created these codes. I didn't, and you don't need to. Prompt flow will take care of that for us. But before we go and run the GitHub Actions CI/CD pipeline, change a couple of things. Come to the run here. You need to make sure you change the connection name to the OpenAI connection name that you created. Remember I showed you, you go to the prompt flow connections, and then you create a connection to Azure OpenAI and save that name. This is mine. If you use another name, change it and actually add it here, here, and here. Second thing, if the deployment that you have in Azure OpenAI for your GPT 3.5 model, and that's a different name, make sure you change that name here. Usually that's the default, so most likely you don't need to change it. And lastly, the runtime. Remember I told you need to create a compute to run your prompt flow? That's that compute name. Where is it? I go to the runtime. This is the one I created. Yours gonna be again different. And I think in run evaluation, you have to change the same thing. Yes, the same thing here. So run evaluation. Okay, make sure you change these. What? Runtime name, connection name, and if needed, the deployment name of your models in Azure OpenAI. Okay, so I come to the workflow. As soon as you make any changes here, let me make a change. It will enable our CI/CD pipelines. So under work actions workflow, these are the pipelines. The first one gonna run our prompt flow, deployed and evaluated, and second, this one, it will deploy it as an endpoint. So let's see what the first one does. You will see that here it is connected to a couple of credentials, like what's my Azure ML workspace, what's my subscription. We haven't added any of these to the GitHub. Remember we created a service principal? We need to add it. So how we could do so? Before we continue, go to the settings of this project, go to secrets and values, actions, make sure you click on new repository secret and name it Azure credentials. So like this, you click on here, you add it, and then paste the file that you copied from your bash code in Cloud Shell. That service principal information that I told you it's credential, paste it here and then click on add secret. I already did, that's mine here. 3 more things you need to do, the same thing, click on repository secret, write type group like this one. That's gonna be your resource group name that you have your Azure ML workspace. Subscription ID, you need to create a subscription ID and add it there and name it as subscription. And the name of your Azure ML workspace should be added as a workspace as a secret. I think if you add them as a variable, so do the same thing, it should be fine, but I added as a secret just in case. I think yeah, the code uses actually secret. Okay, So we added our credentials. Now this GitHub action knows how to connect to my Azure ML, prompt flow, and deploy. So let's go back to our um, YAML files for GitHub Actions. So now these environment values can be captured, and you will see here this is calling uh, the Python, I think the CLI and the Python SDK of PromptFlow. These are recent packages called PF PromptFlow Azure to run the evaluation of the YAML, which is on the web classification. I just showed you we made some changes. Then it grabbed the output of the evaluation to see how good it is. If it's good enough, passing a threshold, it will register it as a model. So use this definitely as a template. But before I run this, again, if I make any changes, it will run this one. And let me actually do a test. Let's say I want to go to run evaluation. I want to make a change. Like, let me add another 2 dots here. Click on commit the changes, commit, and now if I go back to actions, you'll see I updated something, and this triggered actually a CI pipeline for me. So this will run, evaluate my web app classification prompt flow, and then if it passed the threshold of accuracy, let's say more than 90%, then it will register it as a model in Azure ML. Because it's gonna take a bit of time, I ran this before. That's why when I clicked on actions, you saw that I have this executed properly. So let me show you the results. So when I logged in, it do some configurations, installing the packages, stuff needed, and then it ran my prompt flow, the one that does web classification. That's why suddenly when I came to the flows here, I saw that, oh, on the runs, I have a web classification run successfully, not by me, by GitHub Actions. Okay, so coming in here, you will see that it uploaded successfully. If I scroll down, I think there is a section that evaluate, and it will show also the results of evaluation. For example, this is the input example, and the output was app. Good. And then that's it. So I have some metrics being shown by the prompt flow, like how it took, how long it took, the performance stuff. These are all different CLI codes. And that's it. So after that, if the accuracy is good enough, it will register that as a model, and registering as a prompt flow. Again, I'm getting the evaluation results from the previous step, loaded to a temporary file, and then let's see if I have it. Yeah, there you go, register the model here. So it will use AZCLI model create. Where is that model? It's in the YAML file under deployment, and it has registered my model. That means it is ready for deployment. But before we deploy, let's see what happened to Azure ML. I saw that, well, web classification has been deployed. There you go, it tested successfully. 3 of them got completed. There were some examples I showed you. There you go. It was given URL and the output category. These are the ones that I showed you in the results of the CI/CD, right? And then not only that, there's another one. Look, there's another one running because we just make a change. So the other one is evaluating. I showed you before. It evaluated that. The ground truth was app. The prediction was that. That's like a bulk test. And then it should register the model also because the accuracy was 100%. So I went to the models, and there you go. I see the web classification, which is a prompt flow now added and registered for me successfully. Now I can go to the CD pipeline to deploy this as an endpoint. So if I go back to my GitHub Actions, you can trigger this deployment by yourself. Here I did it manually, or you can define a trigger for that. For example, when CI is done, have a request that someone approve it and then run this workflow, which is deploying an endpoint. So if I clicked on this, it deployed successfully, but for invoking that, it got me an error. I want to show you how I resolved that error. So when this endpoint is deployed, you need to give permission as Azure ML data scientist to the Azure ML workspace that you created this endpoint out of it. So make sure you do this. Give this role to your endpoint for letting your endpoint access into the Azure ML workspace that you have deployed this. That was the trick. I resolved that and it worked. So after running this one, which ran all the time here, I went to the endpoint and I saw that, oh, there's a web classification endpoint created for me that now I have the REST endpoint. I can share it with people. It's deployed successfully. And if anyone has this endpoint, and of course with permission and authentication, what they can do, they can just give a URL here and just test or call it. It will give us, this is a URL for a video, for an application, for documentation, or what, or from JSON. Or if you want to consume as a code, there's an example of how you consume as a Python, C# or R for using your web application, web classification prompt flow. So going back again, what we did, we successfully, okay, let me go back to the code. So using this repository, we had a web classification app that used OpenAI model. We deployed that from the code that we had in repo to our Azure prompt flow. We deployed and ran it there. Then we evaluate that using bulk tests. By the way, when you say evaluation, how did you get some data set, some sample data set to evaluate? It was already in the repo. If I go to the prompt flow, I think on the evaluation, accuracy, you see there's a data JSON. There you go. That was the example that we saw that it was deployed in prompt flow to test the solution. Okay. So we tested that, and there is actually a threshold to pass. If we pass the threshold of the accuracy, let's say more than 90%, then it registered that as a model in Azure ML. We saw that. And then with the second GitHub action, which is CD part, we deployed that as a real-time endpoint so people can call and leverage our application. That deployment could be done in a staging in another Azure ML workspace to run it for a couple of days, or the same deployment will be running over a prod Azure ML workspace to have that final solution works. So that was a very simple, short example of how we apply CI/CD, GitHub Actions with PromptFlow. And PromptFlow recently added PromptFlow SDK, PromptFlow CLI, and Code Approach. These are pretty recent. So it is pretty evolving. Write it down in the comments. What do you think? What do you think is still missing? And this community need to get evolved. The feature maybe need to get evolved to make it more and more mature. But I think that's a perfect time and worth to discuss this, see that in action, and I hope you enjoyed this video. That's all.
You are not supposed to know. Life is a mystery. And if you take away the mystery and everything was certain, then you wouldn't need faith. Faith functions the best when you don't know. Dream big, my friends, believe in yourself, and take action. Till next video, take a good care.